Right, hello and welcome back to the next series of videos looking at the Unreal Material Editor. In this one we're going to be looking at the input data, ways we can get information from other parts of our engine into our materials to do various things with. So if we open up this one, input data, first one we have briefly touched on in a couple of the other examples, but we're just going to be going in more detail into these ones now. So position, orientation and scale. Okay. So this set of nodes gives us information about where our object is in the world. So object position, if you press Control and Alt at the same time, gives you a tooltip. It gives us the world space center position of the object's bounds. So it's not the pivot point of the mesh, but rather the point that's in the center of the object. And then it just gives us that as a 3 vector. So if we plug that into emissive, well, if we plug it in directly, we're going to get some very bright values. Again, this viewport not so useful because it's quite different in world position. The world 0 and the object are very close here, but you can see here very bright, and so we want to divide by a very big number as well, and just scale that down. So here 1024. I apply that, now we're getting this kind of pink color, and that's basically a color representation of this position here, 500 minus 600. If I move it this way, now we've gone to negative numbers in red and green and 0 in blue, which is giving us this color, and we can scale this around and we can move it up, and you can see we're getting, because we're using emissive, we're going to get brightness, but it's taking this value, or rather not this value, but the center point of the object bounds, so a value very similar to this, and representing it as a color that we can see. Object orientation does the same thing, where it takes the object direction or forward vector and outputs that. So if I go over here, we don't want to be dividing this by a crazy high number. Let's try this, just divide by 1. So here our facing vector is in that axis. As we rotate this round, we get different values depending on which way it's facing, and you can see we get different orientation values. Last one, object radius. This is going to be to do with the scale of the object. So in this case we will divide by a big number, and as we scale our object up it gets whiter, and as we scale it down it gets darker. And so all of this information from the model can be calculated or can be imported into our material. And the last one, actor position. This does actually take the pivot, I believe. So it will take the actor's location, which in this case here on this blueprint is where my sort of gizmo is. So lots of information we can get about where our object is, where it is, which way is it facing, how big is it, and use that to dynamically affect our materials. One thing to note, this is exactly the same for all parts of the model. So all of these 3 things here are consistent over the, or 4 things really, are consistent over the whole model. So that means it's really good for doing randomization. So if you've got 3 or 4 objects that are similar and you want to randomize something about the material, you probably want to use the object position to do that, and that's what we have down here. And so what I've done is I've taken the object position, which is the center point of the bounding box. I've masked out the red channel, so we're getting variation across the red axis. We're ignoring anything in the green or blue axis. I've divided by a value to give it some control over the scale, and then I've just taken a frac here. So I'm converting the repeating values here, or the linear values here, into something which is repeating. And then I'm just going to randomize, in this case, a value between 0 and 1. Well, what does that look like? Well, if I take my object here, I'm just going to reset some of these values. Let's go, does that work? That's the one control, there we are. So if I make a few of these, you can probably already see what's happening, is there's some flickering happening. Basically it's using the position in the x-axis here as a seed, as a way of randomizing, in this case just a value between 0 and 1. And although you can kind of see a little bit of a pattern sometimes, the randomization is there. It's deterministic, as in it's using the input value to create randomization, and it's driven by that scale value. So if I go back to my material here, let's do a quick side by side. So if I set the variation scale, if I set this down to a very small value, they're going to be very similar all the way. And you can see as I kind of adjust this value, with very big values, the variation is very low. Very small values, the variation is a lot. And you can see we're getting lots of flickering. Now this is a fantastic way to do object randomization, and we'll cover that as a worked example when we get to the environment pieces. But one thing it can't do is deal with any kind of moving object. If this moves around, obviously you see we have flickering here. So yeah, object position random. It's a really nice way of adding more detail to your scene based on just where the object is. Really good for static things while building. Okay, let's just connect this one up to the emissive color. So what's happening here? Well, we're going to fake some lighting. So in this case, if you wanted to create two or some lighting on an object based on a position, we need to convert a position into a direction vector. So we've looked at the dot product in the previous series of lessons. We need a dot. We're going to compare the vertex normals to a direction vector. We haven't plugged in a light direction here. Instead, we plugged in a light position. And so effectively what we're doing, if I do a quick sketch, we have our sphere and we have our light position. We're taking the object's position, so the center point here. We're taking the light's position, and because we're subtracting one from the other, effectively we're getting this direction vector. We're giving ourselves the direction between the two objects. Subtracting one position from another gives you the vector between them. Now we know once we've done that, we then need to normalize to get the direction with a unit length of 1, and we can compare that to the vertex normals, and we can create a lighting calculation. So here in this example, I go over here and just clear that up again. Our light position is at 0. If I put my light position, let's say 50 units in red, we have got a I'm subtracting the wrong one from the other. Let's try swapping those over. That makes more sense. Let's apply this. So effectively we're using a light position here, 50 units in X. Well, that's about here, and we're comparing that as if that's lighting the thing. If we put this up, maybe 50 units in blue as well, we're moving that up. So we're calculating the direction vector between our invisible light source, or our fake light source, and the object, and that's giving us this this fake lighting. So we could have done this with a direction, but in this case we're doing it with a position, and creating the direction by subtracting the object position, because we know the object is always going to be here, and you can adjust that as you wish. So quite a nice way of converting position to direction. If we're doing kind of fake lighting with VFX and magic, that kind of stuff, it can be quite useful to do this. And obviously you can just move the position. Where this becomes very powerful is when you have something in the scene, an actor or a I don't know, an object or something like that, and you can plug this information in via code, via gameplay. At that point, something's moving around and it's creating this fake lighting position, that kind of thing. Previously, I've done things like planets. If you've got a planet orbiting a sun, you don't want the sun calculating light. You can use these kinds of calculations to sort of fake that instead as a cheaper alternative, which works quite nicely. Okay, so that's object position, orientation, radius, and actor position. Just information about the actor, or the mesh, or whatever it is we're rendering, where it is, which way is it facing, how big is it, and ways we can use that either with creating randomization, or in this case, calculating directions between objects, and using that to fake lighting, or to create sort of dot product based comparisons.